Hi everyone, it's time for section 6.3. 6.3 is about higher degree polynomials. Really, it's about diving a little bit deeper into polynomials. We're going to talk end behavior, and we're going to learn how to write polynomials based on the roots and their graph. So here we go, jumping in. So this first polynomial that we've given is presented in factored form. So when a polynomial is presented in factored form, it means that it's a kind of a string of stuff being multiplied together. Each of these is a factor of the polynomial. The zeros, in order to find the zeros are the x values that cause the whole function to equal 0. So we would set our factors equal to 0 and solve. And you would do that for each factor, and what you're going to end up with for your zeros would be 3, 5, and 4. So the zeros are the x values that cause the entire function to equal 0. What is the degree? So we learned yesterday the degree is the highest exponent on our x. It's not kind of in-your-face explicit because this is factored form, so we're going to count. So if I count my x's, I have 1, 2, 3. Kind of looks like 3 x's, so we think this might be cubic, except this x is being squared. So because this x is squared, if we think about these leading terms, we would have x times x times x squared, which means we would actually have a fourth degree polynomial. So the degree would be 4. So we're in a quartic situation. What are the roots? Roots are the same thing as the zeros. It's just another terminology for the zeros. So when we say what are the roots, what are the zeros, we're basically talking about the same thing. How many roots should f of x have? Well, f of x should have 4 roots. And the reason it should have 4 roots is because the degree is 4, and the number of roots should match the degree. So why do we only have 3 roots? Because that x minus 4 is being squared, which implies then that x equals 4 is called a repeated root. We can also use some like kind of fancy mathematical jargon and say that that x equals 4 has a multiplicity of 2. So because of that, if we're actually listing out the roots explicitly, we would have 3, 5, 4, and 4. But traditionally, we don't list a repeated root twice. It's just the roots are 3, 5, and 4. The only difference is that that 4 technically it occurs twice, and it just alters how the graph looks. Here, let's move on. All right, end behavior. We're not going to get too deep into this. Just know that end behavior is what is going on at the far ends of the graph. So if we're talking like if we look at these two graphs, so the blue graph 4x cubed and the red graph is the 4x cubed minus 120x squared plus 900x. So if we're looking in the middle of the graph, they look really different. They look like completely different graphs, right? But if we zoom out and zoom out more, and zoom out way more. So like we're talking about to the millions on the y-axis and to the hundreds on the x-axis. The middle is just kind of doesn't become so significant anymore. Everything kind of flattens out, and really the only thing that you see are the ends. So what we're going to talk about with the ends is we're going to talk about a left end and a right end. The left end is as x goes all the way to negative infinity. So the left side of the graph, we're looking as far left as we could possibly think. So for our left end behavior, we would say as x approaches negative infinity, what is y pointing at? So as on the left side of the graph, what y values is y pointing to? It's pointing to negative infinity. For our right end behavior, we would say as x approaches positive infinity, because now we're going way out here on the far, far right-hand side of the graph. As x approaches infinity, what y value is our graph pointing to? So as x approaches infinity, our y is pointing up to positive infinity. Now your book is going to use the terminology as x increases, y increases, and as x decreases, y decreases, which is fine, and it gives you a decent understanding of the end behavior. But I tend to like this terminology better because it sets you up better for limits in the future. Moving right along. Okay, so we've done this once today. We're going to do it again just to make sure you get it, but we're going to now connect it to the graph. So we have a polynomial, has x-intercepts 3, 5, and -4, and a y-intercept at 180. So the first thing we're going to do is write the function. And remember, what do? We use the x-intercepts and we write them as factors. So the 3 becomes an x minus 3. Then the 5 becomes an x minus 5, and the -4 becomes an x plus 4. But we also need to remember that there's going to be a dilation factor. So I'm going to put an A for our dilation factor. Then we're going to use our y-intercept to find A. So we replace the y with 180, and we replace all our x's with zeros. When we multiply -3 times -5 times 4 together, we get 60. Again, doesn't always happen, just happens to happen on these examples. So we divide both sides by 60, and we get A equals 3. So our final function would be y equals 3 times x minus 3 times x minus 5 times x plus 4. All right, let's take a look at what this graph looks like now. All right, so the first thing I'm going to do when I sketch my graph is I'm going to sketch my x-intercept. So I have an x-intercept at 3, I have an x-intercept at 5, and I have an x-intercept at -4. All right, then I have a y-intercept way up at 180, so I'm just going to say that that's 180. We'll just put that that's super way up high. All right, how do we know what the ends are doing? If your A is positive, then your graph is going to go down to the left and up to the right. If your A is negative, it's going to do the opposite. So when we sketch, I'm going to keep it red. So when we sketch our graph, the left end is going to point down and the right end is going to point up. Now, how do we fill in the middle? There are no repeated roots, so we end up just kind of connecting the dots with a natural flow. So if we are going from here, I'm going to just kind of go down and go up, and then to get through 180, I'm going to go up and go down, and then I keep going down like that. So just remember, if your dilation factor is positive, then your left end's going to point down, your right end's going to point up. If A is negative, then it's going to do the opposite, and that'll help guide your graph to know how to sketch your graph. All right, 5th degree polynomial with a positive A. 5th degree means we're going to have 5 roots. They didn't say where, so I'm just going to pick 5 random spots. All right, 5th degree, positive A means the right end's going to point up, left end's going to point down, and then you connect. I don't know why I think this looks like a sea monster, but here we go. So down and up and down and up and down. Just make sure it just looks kind of smooth. There shouldn't be any sharp turns or anything like that. Just a nice smooth curve. Last one, we have to learn how to multiply factors together, which you've done it for years, but we're going to do it again with imaginary numbers this time, just to make sure we remember. All right, so write a polynomial in general form with real coefficients and zeros at 2, so a factor would be x minus 2, -5, so the factor would be x plus 5, and 3 plus 4i, x minus the quantity 3 plus 4i. So we have an issue. You can't have just one imaginary factor. You've got to have 2. It's just It's just how it is. If we only had one, we would end up with non-real coefficients and it wouldn't be a polynomial. So the only way to convert this into a polynomial with real coefficients is to also include this number's what's called its complex conjugate. So the complex conjugate means you're just going to change the sign that separates the terms. So you're going to do 3 minus 4i. So whenever you have an imaginary part root to your function, you have to also include its conjugate. Even if it's not listed, you have to put it there. No way around it. Got to put it there. All right. So now we've got to convert this to general form. General form just means multiply everything out. So I'm going to multiply these two real factors first. So x squared plus 5x minus 2x minus 10. All right. These guys, I'm not going to multiply out yet. I'm going to distribute those negatives. So I have x minus 3 minus 4i and x minus 3 plus 4i. All right, so for my first expression, all I'm going to do is combine like terms. So that 5x minus 2x is going to become a plus 3x. All right, let's start distributing. So when I distribute trinomials times trinomials or anything like that, I take my first term and I multiply it by all three of these. So x times x is x squared. X times negative 3 is negative 3x. X times 4i is plus 4ix. Then I move on to the 3, and I multiply the 3 by all three of these terms. So I have negative 3 times x is negative 3x. My stylus is giving me issues here. That's a 3. Negative 3 times negative 3 is plus 9, and negative 3 times 4i is negative 12i. All right, then I'm going to multiply my negative 4i times all three of these terms. So minus 4ix plus 12i and minus 16i squared. All right, let's combine some like terms. So we have x squared, no other x squareds there. Use a different color. Minus 3x minus 3x becomes minus 6x. So we have minus 6x. And then look at this. All of our imaginary parts go away. 4ix and negative 4ix cancel. Negative 12i and positive 12i cancel. So the only things that we are left with is this plus 9 and this negative 16i squared. But what does I squared equal? It equals negative 1, right? So this is actually negative 16 times negative 1, or positive 16. And what's 9 plus 16? It's 25, 24, if I can. No, 25. I'm right. I'm not crazy. All right. Okay, so now we got to multiply these together. Here we go. First term times all three of these. So we get x to the 4th minus 6x cubed plus 25x squared. I don't know why my stylus is not working well right now. All right, next term, plus 3x cubed minus 18x squared plus 75x. And last term, that negative 10, minus 10x squared plus 60x, and then minus 250. So our final answer is x to the 4th. I'm going to kind of cross off as I go. X to the 4th. So now minus 3x cubed plus 3x cubed, or minus 6x cubed plus 3x cubed is minus 3x cubed. There we go. All right, x squareds, 25 minus 18 is 7, minus 10 is negative 3. minus, that's when I write the number 3. I'm getting backlash. All right, getting there. Plus 75 plus 60, so plus 135 x's. And our final constant minus 250. All right, we did it. Well done. Good work today. Have